Okay, students, now we're going to look at how the graph of a direct variation relationship would work. So what we're going to do is we're going to look at an equation that is a direct variation, and we're going to talk about the different properties that the graph would have. So if we're looking here at this first problem, it says the cost y in dollars for x gigabytes of data on an internet plan is represented by the equation y equals 10x. So in our last lesson, we learned that a direct variation has the equation y equals mx. And we know that m is the slope or the unit rate. So when we're looking at the equation y equals 10x, that tells us that 10 is our unit rate. Now this problem is talking about dollars, and it's talking about gigabytes of data. So what we're looking at here is that we're going to be paying $10 per gig of data. Okay, so when we're looking at the graph, we're going to have two things if it's a direct variation. Number one, it's going to pass through 0, 0. Number two, it's going to be a straight line. So what we're going to talk about is how to draw this graph. And so we're going to draw the graph by making a table of values. So to make our table of values, we're going to figure out the cost based on our input x. How many gigs of data do we use? So we're going to make a chart to help us figure that out. So our equation is y equals 10x. This is called an H chart, and we're going to be working on H charts throughout this whole chapter. And so we're going to say, okay, well, what if we use 1 gig of data? What would our cost be? Well, y is our cost, so our cost would be $10 times 1 gig, or $10, which is our unit rate. So that's our first ordered pair that we're going to graph, 1, 10. Okay, then we're going to say, well, what if we use 2 gigs of data? Y equals 10 times 2. So if we use 2 gigs of data, we're going to pay $20. That's our next ordered pair, 2, 20. And we could continue going. So what we want to do is we want to get a grid using some graph paper, and we're going to graph these points. Now it's always best if we can graph using graph paper. So what we're going to do is on your graph paper, you're going to draw your coordinate plane. And you can make, again, this is our x-axis. You can make the scale whatever you want. And my y-axis, I'm going to go by tens. 10, 20, 30, 40. So at $1, or at 1 gig, I'm paying $10. At 2 gigs, I'm paying $20. At 3 gigs, I'm paying $30. And this is my graph of my proportional relationship. So I can see it starts at 0, 0, and it is a straight line. So it is a direct variation. Okay, let's look at another problem. This one says the weight y of an object on Titan, one of Saturn's moons, is proportional to the weight x on Earth. So y is talking about the weight on Titan. X is talking about the weight on Earth. It's important to know what our variables represent. So an object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. So we want to come up with the equation. So remember that our equation is always in the format y equals kx or mx. And so y represents Titan. So it tells us that it weighs 15 pounds on Titan. So Titan would go in place of y. Then it tells us that the object weighs 105 pounds on Earth. So 105 would go in place of x. So we have, in place of Titan, 15 equals k times 105. So now this is a one-step equation. We need to solve for k by dividing both sides by 105. And that tells us k is, this is a fraction, I can just reduce the fraction by dividing by 5. So I end up with 3 over 105 divided by 5 is 21. Oh, I can simplify that even further to 1/7. So I had to squish there a little bit. So k equals 1/7. That's our unit rate. And remember that we're comparing, again, our weight on Earth to our weight on Titan. So our weight on Titan is 1/7 of our weight on Earth. Okay? Then it says, how much do you think a chunk of ice that weighs 3.5 pounds on Titan? Oh, I'm going to do that in pink because I want to keep all of Titan in pink. So let me erase really quick. So Titan is in pink. So this is Titan. So I go right back to my equation, y equals kx, but now I know k. So in place of k, I plug in 1/7. And I also know y because it told me the weight on Titan, 3.5. So now I'm solving for x. So to solve this equation for x, I'm going to write it over here a little neater because I ran into my y there. So I have 3.5 equals 1/7 x. So to get rid of the 1/7, I would multiply by the reciprocal, 7 over 1. Back to solving equations from chapter 3. 3.5 times 7, it would weigh 24.5 pounds on Earth. So again, once we get our equation and we know k, then we could plug in any weight for anything on one of the locations, Earth, and solve for its weight on Titan, or vice versa. So again, when we're looking at our graph, we're solving equations, we're making tables of values, we know that we are passing through 0, 0, and that we have a straight line. And our equation for a direct variation is y equals kx. So we're going to continue working on using our equation, y equals kx, and drawing a graph or finding values using the equation.